Sounds great. Thanks for the introduction and apologies to everybody for the audio mishap here. So uh, as stated, my name is Matthew DiDonato. I lead the product development team within GE Healthcare that is building out an AI platform to accelerate AI development within GE. And that means that myself and my team work across all of GE's business segments to develop AI solutions that accelerate our MR, X-ray, CT, all of the imaging devices, as well as all of the other sort of devices and areas that GE plays. So it's an exciting place to work, and I'd love to also highlight some of the great work that I think we've done. And I appreciate the opportunity to speak here, as well as to highlight sort of the exciting things going on with AI and healthcare in general. Today, I'm going to focus in on the dynamics of building AI within healthcare, but mostly actually around the importance of workflow integration and actually having applications be consumed in a healthcare setting. So to start, I really want to start by saying it's an exciting time in healthcare. It's clear, given the number of talks about healthcare within the conference and today overall, that there's a ton of opportunity for healthcare to expand its horizons. And I think a lot of that is centered around AI. And while it's true that sometimes healthcare can be behind other industries, sometimes that's for good reason. Regulatory processes ensure that the solutions that we build are tested and validated. And the reality is, especially when we're talking about clinical settings, we're dealing with critical treatment decisions. And so quality needs to be paramount. However, the fact that sometimes healthcare lags behind other industries also creates a ton of opportunity to fill that gap that other unregulated industries have sort of already taken full advantage of. From a technology perspective, access to compute has never been better. And that's true on the edge, as well as now with the ability to leverage scalable compute in the cloud. That really opens up a number of opportunities for technologies. It paves the way for traditional machine learning, the advancements we now have with deep learning, as well as virtual care in general. There are a ton of opportunities and technologies that we can now deploy in healthcare. Certainly, that's aided by the fact that the amount of data is exploding, and that's thanks to an increased amount of imaging, new imaging techniques, the consumer devices that we all have at our home, and are wearing, phones, watches. The list keeps growing, and I seem to always be buying, and I know that others are as well. So the data outside of just a clinical context that could be related to healthcare is exploding. That's true even genomic data. If you look at it, I think the Human Genome Project took 13 years, and now we're at a point where we're down to a couple hours after, ordering a test on the internet. So the data is exploding, and with COVID, we're now even more familiar with what that means at the population level, sort of population health and measures, and the reality of how they impact us both on the macro scale and on the micro individual scale. So that combination of technology and that can be enhanced by data really allows us to move towards an approach that is more proactive than the system that historically has been more reactive. And it allows us to take preemptive measures, ensuring that we could potentially avoid the most severe consequences, critical conditions, and subsequently potentially reduce costs by avoiding costly treatments in some of those cases. And that's being reflected in conversations about fee-for-service versus value-based care payments. And so overall, like I said, it's an exciting time to be in healthcare. Over the coming years, as we implement all of these things, patient outcomes, healthcare overall will increase, and so will the cost associated with it. So the opportunities really do seem endless. if you look at things from a different lens, I think it's always interesting to look to see where an industry is going by how money is being spent. And certainly all of this was true before COVID, but even more so now with the acceleration of telehealth, virtual care, and the general increasing importance of innovative digital solutions to keep us safe overall. When we specifically look at AI in that lens, there's a pretty clear consensus that there's potential, with over 80% of healthcare leaders saying that they see real growth or the ability to use AI to create savings. And so like there is the confluence of not only the ability to sort of do this from a technical perspective, but real business value. And those two things driven together are a recipe for real change. If you look at the second half of this, the reason that there's money being spent here is that there's real value and takeaways. Last year alone, $40 billion were spent funding startups and new companies in the AI, in the combination and confluence of AI and healthcare. And when we look at where that's being spent, there's a couple key places. If we look at it just from a clinical lens, there's some really, ripe opportunities. And that's everything from patient triaging. So quickly determining who needs immediate care and what that care is. Things like decision support. So navigating the complexities of comorbidities and keeping up with the latest research out there. Things like assistance and generally assistance around the interpretation of results. And that can span everything from radiology, results from imaging equipment, vital sign monitors, lab tests. There's a number of places where interpretation help can be useful. And then there's a big bucket around structured reports and reporting in general. This is actually an area where we start to create a virtuous cycle where data input is time consuming and can be a pain point, and certainly AI can help there. As we do that, we actually start to build a corpus or a set of data that is really structured and becomes the backbone and the basis for even more AI models. And so we can create a virtuous cycle with that last one. But the point is, when we look at things from a clinical context, there's a ton of places where AI can help. And that certainly sounds great. And it seems simple. Like, okay, AI is a new technology and we have data and the computational power to provide it. Let's go forward. And it seems quite simple. I think what's interesting is actually that, well, there's clearly promise for AI. The reality is, especially when we start to talk about adoption, that the clinical context and the clinical reality is complex. Clinical workflows involve a number of different individuals with different skill sets and expertise that span a number of different software systems and data silos. For those that are familiar with some healthcare acronyms, data's in the EMR, the RIS, the PACS, the VNA. It sits in individual medical devices spanning everything from vital sign monitors on a patient all the way to large imaging equipment. When you add on top of that these systems differ between hospitals and geographies, life gets even more complex. And so when we think about building AI solutions and deploying them, we can't remove ourselves from the complexity of these workflows. Because I'm from GE, I want to talk about how we're attacking injecting AI into this complex world of clinical workflows. And I want to talk about it from an imaging workflow context. And if you're a clinician, you might have already picked that up from the graphic here. But I really do think that a lot of these concepts generalize well, and clinical workflows with or without imaging are complex. And so everything will be imaging focused, but I think that this can be applied many other places. So if we believe that clinical workflows are complex, what can we do about that? I think the way we like to think about it is looking at what is the greatest way to actually have this impact an end user. And the reality is change is difficult, and it's due to a number of different factors. Certainly, there can be significant consequences to changing how we clinically do things. On top of that, there's cultural inertia, and that can be strong. Additional systems, screens, applications, deviations from what people are used to provide significant and real difficulties to getting new solutions adopted, because in the near term, they can really slow people down. So I think the question we like to ask ourselves is, how can we make AI invisible? How can we meet our users in their existing workflows? I think Andrew Ng from Stanford actually has a great saying around this. He says AI is the new electricity. And if AI is the new electricity, let's think about electricity for a second. When's the last time you thought about having enough power to plug in your next device, or where the power was coming from, or changing your life around where plugs are at? So if AI is the new electricity, why should we ask clinicians to actively thinking about using an AI tool or change their workflows to make sure that they can incorporate it in? We need to find ways to make AI that works as seamlessly as electricity does in our current lives. And to do that, we need to think not only of models, but how they're deployed, where does the compute happen? And what I'd like to do is sort of come back to this workflow and talk about how we're doing that within GE to provide some examples. Let's start with ordering of the scan. In fact, let's go before order entry and actually before the patient even arrives. Let's talk about a real pain point in around no-shows. And so before scans even ordered, GE is working on reducing the number of no-shows. For people that aren't familiar with the term, no-shows has a very specific meaning. So it's somebody that is scheduled to be imaged, but they don't actually show up. And this can account for millions of lost revenue annually. And so taking into account that this is a real pain point around utilization of imaging devices, GE has worked on pulling information and actually predicting when somebody is going to be a no-show. And we've got a solution, smart scheduling, that is based off of pulling demographic and patient information that could be in the RIS, HIS, EMR, the actual scheduling information, as well as information about the environment. We take into account actually the weather forecast for 5 days. And there's probably some joke about, AI helping us to be able to extend those forecasts beyond 5 days. But the idea is those are external factors are big as well. And what we do is actually predict per patient their likelihood of showing up. And so we take this base model, bring it to a site, and then what we actually do is fine tune it within that site. Use the local weather information, use the local information about how patients have historically shown up. And so we end up with a model that is very specific to this site and a solution that is very specific to the site that's using it. And then what we do is produce per patient a likelihood percent of them showing up. And so some patient may be 88% that they're going to show up, and that's pretty darn good. But another patient may have a 15% likelihood that they're going to show up. And when we do that, we can then have the existing solutions that a site has, maybe text messages, phone calls, be used to fit into allow sites to use those existing workflows and striate patients and increase the likelihood that they're going to show up. It's one way we're sort of attacking a problem within healthcare within their existing workflows. So using those same systems, but allowing our solution to strive patients to hook in to those regular mechanisms to make sure somebody shows up. If we walk along that clinical workflow, another thing we're doing is intelligent protocoling. So this is a solution that we have with our CTs and MRs. And for those that aren't familiar with protocoling, the idea is setting up the specifics around how an image would be captured. And Intelligent Protocol Manager, IPM for short, is a cloud-based protocol manager that allows us to take the information about an order, pull that, also understand what a site has from a protocoling standpoint, what devices are available, and what they historically use as settings to capture an image. We then match those two things together, and then when a technologist is going to acquire an image, suggest the right protocol. But even more interesting than that is if that is changed, if a suggested protocol is incorrect, or we change something based off of something else that a patient needs, we collect that information and feed it back. And so we're meeting the technologist within their existing workflow and suggesting something new. So it really is a seamless solution, and it improves, and we collect the information of how things were changed based off of the suggestions that we provided. So again, I think this is a great example of how we can meet healthcare problems in line with where the problem actually is without deviating from the workflow. Another one before a scan actually happens that I want to call out is something, a product we call AirX. And this is an MRI product. And it's really an amazing solution. And what AirX does, if people aren't familiar with MR, so MRI acquisitions, usually what happens is a patient is laying in the MRI, and based off of their positioning, a quick low resolution scan will be done to define actually the coordinates of the image you want to take. And so it's based off of sort of the patient's position within the MRI. And this requires technologist training, and subsequently can actually produce some variability based off of different technologists, because they are then making a decision as to where the acquisition plane will be. So where the image is actually acquired based off of that low resolution scan and their own judgment. What AirX does is takes that low resolution scan, runs it through a number of different AI models, as well as input as to what piece of anatomy you want to image, and then predefines the acquisition plane for you. And what's nice about this is it reduces the time associated with figuring that out. And on top of it, reduces variability across technologists. And I actually have a picture here that's worth showing. So this is the same patient at 3 different time points. And as you can see in the smaller boxes, every time they laid in the MRI, their position was different. But the acquired image, so the larger brain image that you can see across these time points, looks very, very similar, meaning that the acquisition plane was defined correctly, even though the patient was in a different position each time. And so not only does this save time, reduce variability across technologists, but it also allows us to compare against time points. So again, meeting clinicians where they are in their own workflows. To recenter us sort of in those clinical workflows, we've talked about ordering. I want to talk about some solutions within scanning. And so I'll start with an ultrasound solution. And so this is a solution embedded within our ultrasounds that supports breast assessments using ultrasound. And it's actually embedded in the device. So a sonographer would be going about their exam, and if they found a lesion, they can highlight it and then allow AI within the device itself to run an assessment and provide a quantitative assessment against everything that it's been trained on, and provide a score that is aligned to BI-RADS. And for those that aren't familiar with BI-RADS, it's a assessment criteria on the likelihood of a lesion within a breast to be potentially malignant or not. And so we found a solution where if we embed the AI directly in the device, there's no significant training needed. A sonographer would go about their normal workflow, find the lesion, and then be able to run the AI right then and there. So I do find this is another great example of applying AI within an existing workflow. Another one on the scan side is an MR example. There's also an equally applicable CT example here, but using AI not only to accelerate how an image gets taken, but actually how an image gets formed. And so we have a solution called Air Recon DL that actually uses deep learning and AI to form the image itself based off of the raw information from in this case, the magnets in the MRI. And the result is crisper and cleaner images. It also means that the amount of scan time can be reduced while sort of holding quality constant. And given that MRs are expensive and device utilization is a really important factor in the business associated with running an imaging center, this really has a lot of value. And to make it tangible, let me show another image here. So on the left is a conventional acquisition. And on the right here is the same patient, but the reconstruction. So actually forming the MR image itself used AI. And so I'm not a clinician, but certainly it's pretty evident from the picture that there's a lot more clarity using the deep learning network. And I think that this is something that we have spent a ton of time understanding the right way to do this to make sure that the images provide more information, but are also robust and meet all of the quality standards that we want. And this is really exciting. This is an MR example, but we also have deep learning based reconstruction, so image formation itself on the CT front as well. Let me jump to one more scanning solution. So this is a solution within our mobile x-rays, and we call it critical care suite. And I do think that this is really interesting, and we'll roll into the last place in the workflow that I want to talk about, which is sort of reporting. But this is a solution embedded in our x-rays. And what it does is provides checks for both quality and potentially for critical conditions. And to walk through what a flow would look like, if you're a patient that needs a chest x-ray, you would go in, potentially, be coming from the ED or some workflow that would get you to having to need a chest x-ray, have that done, and immediately on the device itself, so with the technologist that's actually acquiring the image, what would come up is first a quality check that says, is the entire set of lungs, because you're doing a chest x-ray, within the x-ray? If it's not, flag this. And that would provide the opportunity to potentially image again so that a patient doesn't need to leave, find out later that the full lungs weren't in the image, and need to go back for subsequent imaging. So there's value up front of just checking to make sure that the image that is acquired is correct. On top of that, it will also, and this seems trivial, but auto rotate the image to be upright. Sometimes based off of patient positioning, that an image that could be acquired may be upside down or sort of oriented slightly different. We have AI that will auto rotate things that, again, seems very small, but if you're a technologist, this will save you a significant amount of time. And then lastly, right now we have a solution that checks for pneumothorax. And if you're not a clinician like me, a pneumothorax is effectively a collapsed lung. And patients that have pneumothoraxes, I don't know if that's the right plural, are potentially critical. And so actually the device can determine if there's a pneumothorax present or not, uh, based off of different workflows within different countries that may pop up directly on the x-ray, or it may be information that is sent with a report to be read by a radiologist later. But again, this is fitting on the device actually in an existing workflow. That last piece that I talked about, sort of embedding something in a report and actually interpreting the images, is the last piece of this imaging workflow that I want to talk about. For those that aren't familiar, the reporting piece and the interpretation piece, especially within medical imaging, take the form of a radiologist usually interpreting an image within PACS, which is the general storage and viewing place for radiologists to work through patients that have been imaged and those images need interpreted. All of that generally takes the form of images formatted in DICOM. For those that aren't familiar, again, think of like JPEG or PNGs. For those that do know and are technical, that analogy breaks down sometimes, but I think it drives the point home that we've now taken something from an imaging device and put it in a common format. And I think that's really important, actually. And the reason it's important is, and it opens up a lot of opportunity. And I'm going to bring us back to actually where the money is spent again. And I'm going to focus on the number that I didn't talk about before. So certainly there's the value of AI and there's the funding for AI. But this 350 number, there have been 350 companies funded in 2019 that are within healthcare. Now, a large portion of those are also working on medical imaging. And having that DICOM standard is great because this means that it's a jumping sort of on place for a number of these companies, and allows work and development to go on outside of companies that are manufacturing the devices themselves. But what's the impact of that sort of 350 companies? It sounds great. It sounds like we're going to have a number of solutions out there. But the reality is when we have that many solutions, it creates something for clinicians that they may not be happy with, which is a need to assess potentially 350 different solutions. And I'm certainly not a doctor. Some of you may be on the call, but I have friends and family who are doctors, and they generally don't have a lot of extra free time at work. So unless there's a particular solution or model or application that is very near and dear to their focus area or research, it's unlikely that they're going to have the time or the desire to really assess which one of these many applications they are interested in. On top of that, sales cycles are long, and getting on approved vendor list for hospitals can be difficult. So if we've got a ton of value being created by small companies out there that have been funded, especially in the AI space, how do we get that back into the healthcare system? How do we integrate them into the complex workflows that we've been talking about? The way we're approaching this within GE is the Edison ecosystem. And so GE wants to solve that problem by being a single trusted source that allows these companies out there that are building AI solutions to solve not only the upfront logistical problems on long sales cycle and being an approved hospital vendor, but also allow our technology to embed their solutions within these clinical workflows. And I'll quickly talk about this in the PACS context. And again, for those that aren't familiar, PACS is where radiologists spend a large portion of their time interpreting images. So to walk through this workflow, we've got images being acquired in a clinical setting that land in PACS. Once that happens, we've got a solution that we call our open AI orchestrator. And you can think of it as a set of business logic or a workflow that the diagram kind of shows here around deciding if a particular study, a particular image that's been acquired is relevant to an AI solution. To give a really tangible example, let's say a chest x-ray comes in to PACS, and say that you don't have those mobile x-rays with the pneumothorax detection that I mentioned before. Can we set up rules that say when a chest x-ray comes in to PACS, we want to run that AI algorithm that detects pneumothorax. And we'll check to see what the scan is, and then let's run the appropriate AI. That can also be true for CTs or MRIs that maybe head MRIs or CTs that should run against stroke algorithms. And so can we provide that check up front, define rules, and then integrate into all of these great companies that have been funded or are building AI solutions? Can we then return the results back into PACS so that they can be used in the existing clinical workflow? And that is what Open AI Orchestrator does. The results themselves can be consumed in a number of different ways. Everything from workflow prioritization, so taking information that the AI solution has produced and then determining that a radiologist work list should flag or move to the top individuals with a critical condition based off of the AI results. Or depending on the solution, if a solution, for example, calls out a particular area of interest, can we display that within PACS? Can we show that to the radiologist within their existing workflow? And can we expand on all of those things to potentially provide mobile alerts or other ways of notifications, all to be defined within that workflow, within that orchestrator workflow itself, where running the AI solution is one piece of it, but also allows us to decide what piece of a clinical workflow we want this to impact. So we can decide when AI is run and how it's consumed. The end result, and this is sort of what it looks like from a high level, GE can effectively deploy their own solutions as well as third-party solutions using this orchestrator and its logic to be consumed in a way that allows clinicians to not change their reading and interpretation workflow. And really the end result is the ability to bring a number of different AI solutions that have been funded and out there into something that can be used by anybody within a hospital system. Let me just pause and say the overall idea here is how can we activate all of the data that exists within hospital, effectively deliver AI into the different pieces of clinical workflows that I talked about, and really liberate caregivers, allow them to not have to think about using AI, but rather have AI seamlessly meet them where they are now, giving them more time to focus on patients and giving them the best information that they could have when making clinical decisions about their patients. That is all I wanted to touch on today. I'd